Hello everyone, I welcome you in lecture number 9 on system of linear equations. In this lecture we will discuss about homogeneous system of linear equations. Also we will understand the meaning of non-homogeneous linear systems and we will discuss types of solutions of homogeneous linear systems. So let's start with definition of homogeneous linear system. A system of linear equations in which all the constant terms are 0 is said to be homogeneous. So the homogeneous system is system in which all the constant terms are 0. So we can see here this is the general form of homogeneous system of m linear equations in n variables x1, x2, xn. So all the constant terms are 0 which are written on right hand side, and if we have this type of system then it is known as homogeneous system. And if at least one constant is non-zero then the system is said to be non-homogeneous system. So if the system is not homogeneous, that means if at least one constant term is non-zero then system is said to be homogeneous. So this is the example of homogeneous linear system of three equations in three variables x1, x2, x3. Here all the constant terms are 0, therefore this system is homogeneous. This is not homogeneous because we have these two non-zero constant terms in first two equations. So here there are non-zero constant terms in the system, so this system is non-homogeneous. Now if we observe this homogeneous system, then we can see this system is always having at least one solution, that is zero solution. If we put x1 equal to x2 equal to x3 equal to 0, then these values of x1, x2, x3 will satisfy each equation of this system. So if system is homogeneous, it always have at least one solution, that is all the variables are 0. This type of solution we can call as zero solution, or another name is trivial solution, because it is obvious. If system is homogeneous, this zero solution or trivial solution is always possible. If we take all the variables equal to 0, then all the equations in this system are automatically satisfied. So if system is homogeneous, it is always having at least one solution known as trivial solution or zero solution. So we can say that homogeneous system is always consistent. So we make this remark: every homogeneous system of linear equations is consistent, since all such systems have this zero solution as a solution. This solution is called the trivial solution, or another name is zero solution, and solutions other than this solution are known as non-trivial solutions. So non-trivial solutions means solution in which at least one variable has non-zero values. So now we know that homogeneous linear system is always consistent. It always have the zero solution or trivial solution. So for any homogeneous system there are two possible solutions, or there are the two possibilities for solutions of homogeneous system. First possibility is system has only the trivial solution. That means system has only unique solution. This is the case of unique solution. But in the case of homogeneous system, that unique solution will be trivial solution or zero solution. So for homogeneous system there are only two possibilities: either system has unique solution which is trivial solution, or system has infinitely many solutions which are known as non-trivial solutions. So non-trivial solutions are nothing but solutions which are different from trivial solution. So for any homogeneous system there are only two possibilities. Either system has unique solution or infinitely many solutions. Unique solution is nothing but zero solution. If homogeneous system has only one solution, then that solution will always be solution in which all the variables are having zero value. So that solution is given name as trivial solution. Another possibility is system has infinitely many solutions. So these solutions include all other solutions in addition to the zero solution. So solutions which are different from trivial solution are known as non-trivial solutions. Now how to decide that whether system which is homogeneous has unique solution or infinitely many solutions, or how to check whether homogeneous system has only the trivial solution or non-trivial solutions. So we see one result which gives the guarantee of non-trivial solutions or infinitely many solutions. So this result says that if in a homogeneous system number of unknowns or number of variables are strictly greater than number of equations, then homogeneous system will always have infinitely many solutions. So a homogeneous system of linear equations always has non-trivial solutions if number of unknowns or number of variables is strictly greater than number of equations. If this condition is satisfied for a homogeneous system, then the solution is always infinite, or the system always has infinitely many solutions or non-trivial solutions. For example, we consider this system which is homogeneous. Here number of variables or number of unknowns are x1, x2, x3, x4, that is 4, and 3 equations. So this is homogeneous system in which number of unknowns equal to 4, which is strictly greater than number of equations, which is 3. Therefore given system has infinitely many solutions. So this system has infinitely many solutions including trivial solutions. Now if system has equal number of variables and equations, then how to decide the type of solution? So for that we make this note. Suppose we have this homogeneous system written in matrix from A into x equal to 0, where A is coefficient matrix. Now suppose in this system the number of variables equal to number of equations. Now if this happens, then this coefficient matrix of given system is always a square matrix. So if determinant of this coefficient matrix is non-zero, then given system has only a trivial solution, that is only a zero solution. If determinant of coefficient matrix is non-zero, then this homogeneous system has unique solution, or this homogeneous system has only a trivial solution. And this system has non-trivial solutions or infinitely many solutions if determinant of coefficient matrix is 0. But we can apply this remark only in the case in which the number of unknowns equal to number of equations. If number of variables and number of equations are same in a homogeneous system, then if the determinant of coefficient matrix is non-zero, system has only a trivial solution. If the determinant of coefficient matrix is 0, system has non-trivial solutions or infinitely many solutions. So we understand this with the help of example. Determine the types of solutions of following linear systems without solving the system. So this is system of 3 linear equations in 3 variables. and all the constant terms are 0. So this is homogeneous system. So given system is homogeneous in which the number of unknowns equal to number of equations. So we write down the coefficient matrix of this system. So first column corresponds to coefficients of x1 which are 1, 2, 1. Then coefficients of x2 are 2, 5, 0. There is no x2 here. So this column corresponds to coefficients of x2. And coefficients of x3 are 3, 3, 8. So this is the coefficient matrix of given system. Now we find out determinant of this coefficient matrix. So we start from 1 and we consider determinant of this matrix 5, 3, 0, 8, which is 40 minus 0. Then minus 2 and determinant of 2, 3, 1, 8, which is 16 minus 3. Then this 3 and determinant of this matrix, which is 0 minus 5. So after simplifying we obtain minus 1. That means determinant of coefficient matrix is non-zero. Therefore given system has only a trivial solution, or given system has unique solution. So this is very easy or useful criteria to decide the type of solution of homogeneous linear system. It depends on the determinant of coefficient matrix, and here determinant of coefficient matrix is non-zero. Therefore given system has only a trivial solution. We consider one more example. This is system of two linear equations in two variables. It is homogeneous and number of variables are 2, number of equations are 2. So we can apply that remark or result. We write down the coefficient matrix, which is 3 minus 2, 6 minus 4, and we check determinant of A, which is minus 2 plus 12, 0. So we obtain 0. Determinant of coefficient matrix is 0. This shows that given system has non-trivial solutions, or given system has infinitely many solutions. We consider one more example. We are given system of two linear equations in two variables x and y. Constant terms are 0, so this is homogeneous system. But in coefficient of x we have lambda minus 3, so lambda is unknown constant. So we are asked to find out values of lambda for which this system has non-trivial solutions, or for which values of lambda this system has infinitely many solutions. So in this system number of variables are 2 and number of equations are 2, and system is homogeneous. So we know that if determinant of coefficient matrix is 0, then this system has non-trivial solutions. So we write down the coefficient matrix and we find out determinant of coefficient matrix. So here we have written given system is homogeneous in which the number of unknowns equal to number of equations, and coefficient matrix is, first row is lambda minus 3, 1 and 1, lambda minus 3. So as we know, given system has non-trivial solutions if determinant of this coefficient matrix is 0. Now determinant of coefficient matrix is 0 implies determinant is lambda minus 3 square minus 1 equal to 0. So we simplify this. This is lambda square minus 6 lambda plus 9 minus 1 equal to 0. So lambda square minus 6 lambda plus 8 equal to 0. Minus 6 lambda can be written as minus 4 lambda minus 2 lambda. Here we can take lambda common, here we can take minus 2 common. So after factorizing we have lambda minus 4 into lambda minus 2 equal to 0. So lambda equal to 4 and lambda equal to 2. So for lambda equal to 4 and lambda equal to 2, this determinant will be 0. So determinant of coefficient matrix is 0 for lambda equal to 4 and 2. Therefore given system has non-trivial solutions for lambda equal to 4 and 2. So this is all about today's session. In this session we have discussed homogeneous linear systems. Homogeneous linear systems are those linear systems in which constant terms are all zero. So it is always consistent. It has always at least one solution, which is zero solution. And if system is consistent, we have only two possibilities for its solution. So for homogeneous system there are only two possibilities for solution. One possibility is only a trivial solution, which is zero solution, values of all the variables are zero, and another possibility is an non-trivial solutions or infinitely many solutions. And we have discussed two results, and so using those two results we can decide the types of solutions, whether it is infinite or unique. So I hope you like this lecture. Thank you very much.